Our industry is pretty unique in the sense that we allow failures. You know, bridges and buildings, you don't allow failures, but utility structures, for some reason, we do allow failures. And we learn from all of those in some form or fashion. You don't want them to happen, but you do tolerate them. You design to a certain load, a certain expected wind load, or a certain expected ice load. And if you're good at predicting what that is, then the structures are not going to fail. But if you find out that they're not meeting that criteria, then it probably will fail. And what you don't want to have happen is it fail because of some reason not related to the design. And I think that's what we get more interest out of than looking at something failed because it just exceeded its wind loading or ice loading, but looking at the things that cause a premature failure, corrosion or weld cracking or fatigue that causes weld cracking or any of those kinds of things. As we've looked back at all the things that EXO did, I think the interesting thing to me is that most of the failures we investigate are not the 30 or 40 or 50-year-old structures or 60 or 70-year-old structures. Most of the failures that we investigate are 10, 12, 13 years. So they're premature failures. They haven't been exposed to, they didn't fail because of an extreme weather event. They failed because of some mistake that was made either during construction or in how they were built or some other issue that just wasn't anticipated. When you have a high voltage, brand new line that's only 10 or 12 years old, it's expected to be up and expected to carry the power that it's supposed to carry. And when it fails, it can be relatively expensive. Number one, the utility has to respond to it at an emergency basis. Number two, may or may not be able to divert power around that particular line, so you're going to have customers that are upset. And number three, it may cause some damage. The genesis of the presentation came from really our thinking about what caused the failures, and it's always the little details that can cause the biggest of problems. And so we came up with an idea to talk about those details, why details matter, whether it be welding details, whether it be corrosion protection details, or whether it be assembly and erection, things that are not going right or not put together right. It's always the little details that cause the biggest of problems. So we started assembling. As we got probably 7 or 8 catastrophic failures into it, we said, well, this was a failure because of fatigue-related cracking in a weld. This was a failure related to not having Sharpie impact toughness properties in the steel that was used to fabricate the base plate. This failure is attributed to something else. So as we started getting into those details, we said, you learn from mistakes, you learn from things that don't go right, and we felt like we needed to share some of those details with the utilities that we work for. You learn from mistakes, you learn from things that don't go right, and we felt like we needed to share some of those details with the utilities that we work for. And I think it's gone over really well. We get a lot of good questions. It's eye-opening because, again, you find that a lot of utilities don't have that experience for themselves necessarily, especially the younger engineers that sometimes attend the calls that we have about it. A lot of the older ones have experienced failures, but a lot of the younger engineers never have. And to me, it just is always encouraging how eye-opening it is that you've got to pay attention to all the details if you want to avoid failures. I'm always amazed that they don't always see the connection between that small little detail and a catastrophic failure that occurs. One example of that is, and we're going through it in the Steel Pole Design Committee right now, is some of the mechanical properties related to maximum tensile strength, some of the mechanical properties related to carbon equivalency in the steel, some of the mechanical properties related to Sharpie V-notch. Those are very benign. Well, I won't say benign, but they're very small details. But if you're not specifying the materials correctly, if you're not paying attention to what those material properties are, and you try to weld them, it can create problems. And so we try to make that connection between that simple little detail and a failure that occurred because of that particular issue. Most people, when they think about a steel pole or a lattice tower, they think it's pretty simple. You take a sheet of steel, you fold it, you weld it, put it together, and you got a structure. But there's 1,000 details that go into that, from getting good mechanical properties in the materials to having welding procedures that are adequately and properly prepared, to welders that are qualified. So when you start thinking about it, you going that far back, most utility engineers, especially the younger ones, don't think too much about that until they experience a problem. Then now they're thinking about it. My experience over the 47 years that I've been doing this is that I've seen a lot of these problems. I've caused a lot of these problems myself. And you think again, oh, that's just a carbon equivalent is just a value. Well, it is just a value, but you better pay attention to it because it affects welding. It affects integrity of the welding. And if you're not paying attention to it, it can lead to hardening of the welds and brittle fracture at some point. One of the things I hope they take away is that most failures are caused by some reason, and they just don't happen. We tend to write off most of these catastrophic failures as a weather event, but when a structure falls down in a weather event that didn't come anywhere near the design weather event that it was designed for, then it makes you start wondering. And most of the failures that we've gotten involved in are just exactly that. Maybe there was a bit of ice, may have been a 1/4 inch ice, but the structure was designed for 1/2 inch ice. Or maybe it was 80-mile-an-hour winds, but the structures are designed for 115-mile-an-hour winds. And so you start thinking through that, okay, well, it was designed for more. Why didn't it achieve that? And I think that's the realization that I hope somebody will take away from it, is that you need to think about why something didn't perform the way it was supposed to perform and try to fix it next time. Most utilities had a very deep bench of technical specialists back in the 60s, 70s, and even into the maybe early 80s. And then all of a sudden, most utilities decided they needed to not hire so many people. And there ended up being a big gap from about probably early 1980s to maybe the late 1990s, where they weren't hiring any engineers. And then all of a sudden in the early 2000s, people started hiring again. So there was a big gap. A lot of the older guys retired. They weren't able to transfer their legacy knowledge. But the younger engineers still needed to have some mentoring. And I think a lot of them were getting some of that, but they weren't getting it from the perspective that we were able to provide. So I think that was kind of the idea behind doing it for the young engineers, not the older engineers that maybe have been around a long time, but the younger engineers. But you don't learn if you don't study failures. And so I think that's one of the things that we try to. We don't point fingers at anybody. I don't name any names when we talk about the failures that we've observed. We don't talk about the suppliers. We don't talk about the utilities. We just said, here's the detail. Here's what happened, and here's why it happened, and go through that whole process of how you got from point A to point B, and that this was the root cause of the failure. And I think that's an important learning aspect of the presentations that we put on. If you're a young engineer or even an old experienced engineer and you want to learn something about the details that matter that cause failures, sign up for EXO's failure presentation. You'll learn something that may prevent something catastrophic from happening on your system.